In this video, I'm going to be looking at parallel and perpendicular lines. If the equation of a line is y equals to mx plus c, and you have it in slope-intercept form, then in order to work out whether two lines are parallel, if two lines are parallel, that means their gradients are the same. And if two lines are perpendicular, i.e. they intersect at 90-degree angles, then their gradients will multiply to -1. So let's have a look at a few examples. So let's say I have the example y equals to 2x take 7 and y equals to 3x plus 1. Are these two lines parallel, perpendicular, or neither? Pause the video and have a go. Well, the only thing that determines whether two lines are parallel or perpendicular is their gradients. And as we can see, because the two gradients of the lines are not the same, that means they're not parallel. And in order for two lines to be perpendicular, we need the two gradients to multiply to -1. And 2 times 3 does not equal -1. So therefore, these two lines are not parallel or perpendicular. What about this example over here? The first step we have to do is we have to work out what the gradient of each of these lines are. So for the first one, the gradient will always be the coefficient or the number in front of the x. And because we know the number in front of the x is 3, that is the gradient. For the second line, the gradient is the number in front of the x, which is -1/3. Now we can tell that these two lines aren't parallel because the gradients aren't the same. So we have to check if they multiply to -1. And because the gradients do multiply to -1, we can tell that these two lines over here are perpendicular, and the symbol for perpendicular is like this. Now, what if we wanted to work out the equation of a line which is parallel or perpendicular to another line? So let's say we wanted to have a look at the line which is parallel to this one, but it passes through the point 4, -2. So we want to find the equation of a line which is parallel to this one, but also passes through this point here. Well, the first thing we need to look at is what will the gradient of this new line be? We know that if two lines are parallel, the gradients have to be the same. So we know the gradient of the new line is y equals 2x, so we know 2 has to be the gradient of the new one, plus c, because we don't know what plus c is just yet. Now I need to use the information that they've given me in the question, which is 4, -2. I know that the y value has to be -2 when x equals to 4. And I can solve this linear equation by doing -2 minus 8 equals to c, and that means c is equal to -10. That means the equation of the parallel line that passes through 4, -2 is y equals to 2x take 10. Let's have a look at one more example. Let's say we wanted to find the equation of a line parallel to this one. And we wanted to once again pass through the coordinates 4, -2. Well, in this example here, it doesn't really look like slope-intercept form, so it's hard to tell what the gradient is. The gradient is not 2, because it's not in slope-intercept form. So what I'm going to do is I'm going to turn it into slope-intercept form. So I can move the 3y to the other sides by doing plus. So 3y equals to 2x take 4. And then I can say that y equals to 2/3x take 4/3. And so now, because I have it in slope-intercept form, I know that my gradient is 2/3. Next, I need to find the equation of a line parallel to this one. And two parallel lines will have the same gradient. So the new line will have an equation which looks like this, where I know the gradient but not the c value. Now, I can use this coordinate that I've been given. I can substitute it and solve for what c is. I know that y equals minus 2 when x equals to 4. And if I wanted to solve this, I would have minus 2 equals to 8 on 3 plus c. And that means that c equals to minus 14 over 3. Therefore, y equals to 2 over 3x, take 14 over 3. Now let's focus on perpendicular lines. I want to find the equation of a line which is perpendicular to this one over here. Again, we'll stick with 4 comma minus 2. Well, the first thing I have to do is I want to make it in slope-intercept form. So I'm going to make it into the form y equals mx plus c. And the way I would do it is by doing this. And that means y equals to minus a third x minus 4 over 3. Now, I know that in order to have two gradients where they are perpendicular to each other, the gradients must multiply to minus 1. So minus 1 over 3 times by some gradient has to equal to minus 1. And if I were to solve this, m would equal to 3. A quick way to find this gradient is you can take the gradient that you originally have, and you can flip the fraction, so it would be minus 3 over 1, and then change the sign of the beginning term. So you would just have the gradient as being 3. So now that you know that the gradient is 3 for the perpendicular line, all you have to work out is what plus c is. So we just substitute the points. And there we have it. That means y equals to 3x take 14. That is the line perpendicular to this line here. You can pause all of these examples and type them into Desmos to verify the answers. Now let's have a look at one last example. I want to find the equation of a line that is perpendicular to this one, but passes through the points 1, 4. Well, it's the same steps again. I need to find the gradient of the new line, which is perpendicular to this one. And the way you would do that is you would take the original gradient, minus 1 over 2. You would flip the fraction, so minus 2 over 1. And then you would change the sign at the front here. So you would change it to plus, and you would make it 2 over 1, or just 2. So the new gradient is just 2. So now that we have the new gradient, what I'm going to do is we can say y equals to 2x plus c. And in order to work out c, it's the same step. We can just substitute in this point here. And that means that c equals to 2. So that means the equation of the new line is y equals to 2x plus 2. And that's parallel and perpendicular lines.